I'm delighted here today to welcome Joe Smyth, the site lead of Genesys. Joe is a veteran of unified communications and contact center. He has worked for Apple, Nortel, and Cisco. He was the CTO and co-founder of a local company in Galway called AltoCloud, an artificial intelligence company, which was acquired by Genesys in February 2018 and is growing exponentially year on year, and they're about to move into a fabulous new location in the docks in Galway, Bonham Key. And then we have Claire Murphy, software engineer, who's a graduate at UCD. Claire will talk to you about her job on a day-to-day basis as working as in computer science. Professor Michael Madden, computer science, NUI Galway. Professor Madden is the head of computer science. He manages a research team developing new techniques in machine learning to solve real world problems in science, engineering, and medicine. And if you want to ask Professor Madden what machine learning is, you'll get an opportunity at the end when we have a Q&A. The Q&A will be moderated by Tara Dalrymple. Tara Dalrymple is the HR Operations Manager, Employee Engagement Officer at Genesys. And employee engagement is so important in tech companies. The competition globally for graduates in computer science is very competitive. I think only recently I heard a number that there was 1 million open roles in cybersecurity, given everything that's happened recently here in Ireland. So these roles, these graduates are in demand. To talk to your students about what it is to work in these companies, the engagement piece is so important to ensure that the employees are number one to the company and that they have a really good experience. So I'm going to hand you over now to Joe Smyth, the site lead at Genesys, and he's going to give you a review of Genesys itself and talk to you about computer science careers. Thank you, Joe.
Yeah, thanks, Anne. Let me just open up the presentation here and start this. Okay. So as Anne said, I'm Joe Smyth. I'm the Senior Vice President of R&D for Digital and AI at Genesys globally. And Claire's going to talk a little bit more later on about the roles, her software engineering role here at Genesys, which is representative of the types of roles that graduates could expect in the industry. So who are Genesys? So Genesys, we're one of the leaders in software communications and particularly contact center software and digital customer service globally. So we handle over 70 billion calls and chats every year between customers and businesses. And that includes, traditional contact center voice calls, self-service, and a big emphasis now coming through on artificial intelligence, as we're trying to make the bot experience better, and we're trying to join up digital and mobile experiences with the call center, so that when you call in with a Genesys enabled call center, they're not asking you what's your problem and who you are. The agent should have the context of that based on your previous interactions with the business, whether that's the mobile application or you've logged in and tried to self-serve on their digital website. All that context can be delivered to the agent to help the agent more quickly serve the customer. And that's what Genesys is all about, and that's what the work we're doing in Galway is primarily about, is bringing machine learning and big data to bear on the contact center area. So we also have some of the biggest customers in the world, Vodafone, AXA, BBVA, probably some of the ones you may know, Microsoft, of course, PayPal, all operate their customer care on top of Genesys software. So I'm just going to step back and talk a little bit about my own career first. I'm originally from Claremorris in County Mayo, and I've been in Galway since 1995 and building my career there. I went to college in UL way back in the 80s and did electronic engineering. When I came out of there, I went to Cork and worked with Apple down there in just the years after Steve Jobs had left, before he came back again. So I was in the interregnum there between the two Steve Jobs era. And a kind of critical moment for me was the 1-year rotation I got into Silicon Valley to work at head office in Cupertino. And it was during that period I kind of discovered that, you know, software engineering wasn't any special skill that only American software engineers could do, as there was a concept at the time, but that, you know, any of us can pick up these skills and be world class at it. So that was a pivotal moment for me when I was a recent graduate back in the early 90s. I was very keen to come back to Galway, and I joined Digital in 1992. And then I ended up back in America for 2 years because I wanted to follow a project that I was very keen on. And I got relocated into New Hampshire and the Boston area for 2 years, which was another growth experience for me. Then I came back to Galway in 1995, started working for Nortel as principal software engineer at that stage. And we worked on voice over IP technologies, and some of the underpinning technologies that's used in Zoom today and other teleconferencing systems was developed by the team I was working in Nortel. And we filed a range of patents on voice over IP, video over the internet, all that technology back in the late 90s. Then in 2007, I joined Cisco, and I spent another 7 years so I had 11 years with Nortel, and then I spent another 7 years with Cisco, 6.5 years with Cisco, doing unified communications and software. At that point, I wanted to, you know, I'd been with large American companies for the bones of, how many years is it? 20 years and 25 years, in fact. And I wanted to do something different. And myself and Barry O'Sullivan, who some of you may know, were discussing over a Christmas drink one time about the end of 2012 about doing a startup. And we had this idea that it was time to start bringing customer care and the internet together. And that was the genesis of AltaCloud. And we started this company called AltaCloud we were based first in NUIG, in the Business Innovation Center there. We built a prototype. We got a first customer. We got some investment from Enterprise Ireland to get us going. We built out our customer base a bit, enough to get us some venture capital. And from there, we grew that over the 5 years until we had grown to about 22 people. And in February 2018, we got acquired by Genesys, which was obviously a joyous occasion, but it was just the start of another round of growth for us. And at that point, we were 22 people here in Galway. We continued building out the team. And here's a picture of us in 2019, we'd grown to 65 people, and Genesys really liked the talent that we were able to hire here in Galway, and the work we were doing, the contribution we were making to the business. So they doubled down, and the first thing we did to build our brand was to start sponsoring Connacht Rugby, which was a very fortuitous moment for us. They were looking for a sponsor. We were looking for a way to build our brand in the area. So we picked up the sponsorship of Connacht Rugby, and it really helped us build our brand in the area and in Ireland. So we've continued to grow. We're at 233 people as of this week, and we're continuing. We'll be heading for over 300 people in 2022. And with that, we need to move into a shiny new office, which is under construction, overlooking Galway Bay at the moment. And we'll have 4 floors of this office space. So that's kind of my journey and the Genesys journey within Galway. But I want to talk now a little bit about software engineering and what it can mean to the kids who are in school today. Software really is changing the world. There isn't any industry that isn't been changed by software. And we see that from music has been upended by Spotify. All video rentals were completely upended by Netflix. And people want this always on experience now, whether it's Netflix or Spotify or YouTube or WhatsApp. It's always connected. I dread to think what the world would have been like if the pandemic had hit even 10 years ago, before we had a lot of these cloud-based technologies that enable us to keep going. And all of these are built on software. The key one there is Zoom, which we're using today. And then with the advent of the smartphone, we're seeing a lot of applications that are changing the way people interact with each other. And there is upsides and downsides to that. We're still, as a society, we're trying to get to grips with how do you deal with software on phones, how do you deal with privacy issues, how do you deal with the way it changes social interactions. But we've seen these kind of shifts through the last 100 years as well, as the world become more urbanized, shift into large cities. This is kind of now we're shifting into the virtual world, and it's something that society needs to work on and deal with. But at the same time, it's this is going to accelerate, and we need to be giving our children the skills they need to succeed in this most vibrant part of the economy. So our kids will have experience with these applications day in, day out. I'm just going to look at Instagram, for example. So, it's all about uploading your photos, about liking photos, about sharing photos and videos. It's a relatively straightforward app, and yet it has a profound impact on the way people work. And here's the Genesys Instagram page. But the roles that go into this to build this product are many and varied. First of all, those UX, user experience designers, who create the look and the feel and make sure the product is easy to use, so that everybody from a 3-year-old to a 90-year-old granddad can use the application. That's the role of user experience. We're gone from the days of having to program a VHS arcane system to using Netflix and to using really easy to use applications. And that's what UX designers have emerged as, to create that environment. We then have the front-end software engineers who actually implement what the UX designers create. Then we have the back-end software engineers who create all the cloud services that store the photos and serve up the photos and the videos and distribute the likes and the comments and all of that, so they can be picked up by thousands and thousands and millions of users. And then we have AI engineers, machine learning engineers, who create the algorithms that decide what photos and videos are shown to each individual person based on their likes and wants. So that's the drive behind machine learning in this platform. And then we have DevOps engineers that scale it up so that millions of people can use it all at the same time. And that's how cloud software has transformed the world, has been able to scale it up to what we call web scale. 10, 15 years ago, the max number of users on a platform was probably 1,000 or 2,000. Now it's millions. And all of these roles, whether it's UX design or computer science, start with a degree in UX design, computer science, or electronic and computing. Okay, so I'm going to hand over to Claire, and Claire is going to talk to us about her experience doing getting into this world of computer science. So Claire, over to you.
Thanks, Joe. Yeah, so I'll just cover, I suppose, my journey from secondary school through college, through to now working as a software engineer. So I work as a front-end software engineer. So as Joe was saying in the previous slide, it's where we take the visualizations that the UX designers have created and we implement them into our apps. So yeah, so where I came from, I am from Neenah in County Tipperary. I went to school in St. Mary's Convent and then subsequently studied engineering in UCD for 3 years. And now, yeah, I'm working in Genesys as a software engineer. So on the right here, you'll see my hobbies. This is just a little bit about me. Like, I love playing, watching sports. I always have. The main ones I have going at the moment are I'm playing football with Gael na Galway in town, and Camogie with Castlegar. So it's great to be back training this week. So I just kind of want to touch on even that they're my hobbies. The hobbies of a software engineer can change. They're not, I suppose, you probably have preconceived notions of what they could be, but it's great in software. There's a huge variety of different people that you can work with different hobbies and different interests. So it's great. Yeah, and so in school, I didn't really know what I wanted to do as a career. I never looked at coding, computers, anything like that in TY like we did Microsoft Office, but that's about the max of it. And then in terms of work experience, these four were the work experience that I did in fourth year in school. So pharmacy, county council, nursing home, fast food van. It kind of, these only really helped me narrow down where I definitely didn't want to work. I still couldn't figure out where I did want to work. So then for Leaving Cert anyway, I chose the subjects I was good at and I liked. So I did physics, chemistry and technology. I kind of went with these as like I do enjoy problem solving. So I kind of felt if I could build a strong basis in these, then I could problem solve any of the exam questions. That's kind of where I kind of went with that. And then when I was looking at my CEO, I kind of had it narrowed down to electronic engineering or computer science, but I definitely didn't really understand the difference between the two. I was probably a little afraid of being expected to work on something by myself, and I kind of thought in terms of my idea of computer science was kind of what Joe alluded to, like these mysterious American Silicon Valley engineers that do something really complicated. So I was kind of probably a bit nervous about that I was afraid I was going to be given, if I went down the computer science route, I'd be given work to do and expected, you know, go away and do that for a month and come back with it done kind of thing. But there is, couldn't be further from the truth. Software engineering is like, it's everything works on a team. You get to work with a variety of different people, and like if you have any issues with it, there's always someone around you or on the team or in the company that can help you get through your work. Yeah, so because of that, because I was kind of afraid of working by myself, I suppose, I don't know, for some reason I thought electronic engineering would be different, so I went with that. So I kind of chose general engineering in UCD. The reason I went with this then was because this is, you know, this course is a broad base. The first year gives you a taste of all the different types of engineering. So I kind of felt like I've narrowed down my options, but I haven't fully committed to it. So first year gave you a good taste of different kinds of engineering, mechanical, civil, biomedical. So you could just keep your options open. But after first year, I did decide to specialize or narrow down further into electronic and electrical engineering. So in engineering, these are the main areas of study. And then in UCD, it's great because you get to pick options. So on the left here, this is a photo of me in first year where we did a robot war competition. So we built robots out of Lego and programmed a small circuit onto it. And I absolutely loved that module. It was really interesting. So that programming bit of programming the robot, I really liked. So in terms of we could pick a lot of options and electives, so I decided to pick up ones that were more kind of towards the School of Computer Science. So ones in C, C++, Java, all kind of programming languages. And then, yeah, so all these kind of programming languages. So as I kind of picked these up, I just, you know, like I did really like them, and I was definitely leaning more towards these options than the main areas of study. So with that realization, I kind of saw that UCD gives students the opportunity to graduate with a Bachelor of Science in engineering science after just 3 years, rather than the traditional Masters of Engineering or the 5-year Masters of Engineering or 4-year Bachelor of Engineering. So I kind of grabbed that opportunity because I said, look, it's electronic engineering isn't for me. I kind of wanted to pursue the computer science software kind of side of things. So before I graduated, I was lucky. I applied to a graduate program in Fidelity. So in Fidelity Investments. Fidelity Investments is a US investment bank. But they have about 1,000 employees in Ireland, and they run a really interesting graduate program where you actually go into training for 6 months. So the first 3 months of this graduate program is classroom training, which kind of sounds like the last thing you might want to do after a computer science degree. But for me, like, it suited perfectly because I didn't do that many computer science modules. I just knew that I liked them. So it was a great opportunity for me to get a bit more classroom training in. So that was the classroom training for the first 3 months. And then the next step of the program was the second 3 months, where within the whole graduate program, there's about 30 graduates, and we got put into teams where we could build something small for the business. And this was pretty cool. So my team, we actually worked on the trading platform that they use on the trading desks in America. So when you make trades, there's a whole lot of infrastructure that goes beneath that. So yeah, so 6 months, I suppose, into my role in Fidelity, I had made, myself and the team, we had made a production change on a trading platform. So that was really wild, and it was really cool, and I really enjoyed that. So said, this is definitely the career for me. So after the 6 months, then Fidelity would place you into a team. So I got placed into a team that worked with storing data and creating data visualizations. And so this was creating pension data visualizations for top level executives. And I really enjoyed that work. I really enjoyed working with data and working with the visualization. So working with the front end of the application, getting as close to the user as you can. But yeah, while I really enjoyed that, after about 3 years, I decided I wanted to kind of get out of Ireland, travel a little bit more. So I moved to Vancouver in Canada, and spent the summer applying for software jobs there. I was absolutely delighted to get started with a job, with a software job there in Central One Credit Union, because this kind of enabled me to balance out, to further my software career, having only 3 years experience, while actually, living abroad. Vancouver is famous for its hikes and its ski season, so I absolutely had a brilliant time over there. But then, yeah, once COVID hit, the classic story, I suppose, I decided to come home. So I came home there in March last year, and then I applied for Genesys. And yeah, so here I am a year later working on the Genesys front end software team. So that's pretty much my whole career, how I got here today. And then this last slide for me is just like, why did I choose a career in software? Why do I like it? The main one is, like, problem solving is at the core of any career in software or in STEM. So, it's kind of, you really acquire that skill, and you get to really practice that skill every single day, because you get different tickets come at you every single day. So you get a huge variety in work, and you get to exercise that problem solving skill. You get to work with cutting edge technologies, especially in Genesys. There's, like I was saying, the variety of stuff that you face is just brilliant. An important one for me, like I was saying earlier, is that the work is done as a team. Like, I'm a social person. I like playing sports. I like, bouncing off people all the time. So this was great for me, that when I actually got into it, it was demystified, and work is done as a team. So I can ask people for help anytime, and people can ask me for help. So it's brilliant. It's very social. And then lastly, the workplace is really flexible and modern. So you've a casual dress code most of the time. You can be flexible with your start time. You can take a long lunch. You can decide when you finish. This kind of stuff, as long as your team is aware of what you're doing and you're making your meetings, and they know when you might be, I'm off for an appointment now, or I'll work late this evening and then I won't start till 12 tomorrow. That kind of flexibility is there, which is brilliant. It's real modern workforce. That's it for me anyway. I'll pass back to Joe here.
Yeah, thanks, Claire. And that's a great summary of how people can come to get into the software industry, and we have many different variants of that story with the people we have hired into Genesys. And in particular, we find that the female staff in particular tend to have much more varied ways of having got into software engineering. And to me, that's you know, we're not as a group making our females in the 4th, 5th years and coming into Leave Insert aware of what a great career software engineering can be for everybody, not just the traditional view of the guy in the corner coding away on a green screen. That's not the representation of what the real world is at all. So just on that, software engineering is a career for all and a huge opportunity for the boys and the girls with any aptitude for maths, physics, or applied maths. You don't have to be, a really critical thing is you don't have to be coding since you were 12. We all, the Collisons were coding since they were 12, and they're just, they're the exception that prove the rule. But the vast majority of people who come into computer science have very little experience of computers and computer science and coding before they start. My own son did his Leave Insert last year. He was going to do financial maths, and then he was looking at the roles, and then he decided, you know what, I'll actually do computer science. I challenged him personally a couple of times to make sure he was making the right decision. But he had no coding experience. He's gone into first year in college, and he's flying through it. So you don't need to have been coding since you were 12 to do computer science. And I know there's a new syllabus class coming on for Leave Insert in computers. Even that I don't think is a prereq. And I think Michael will cover how the colleges upskill the kids right from ground zero. The number of roles, I got this number, 2,000 vacant jobs from the IDA website yesterday. I believe it's significantly understated. That there's at least 2,000 vacant jobs in software engineering in Ireland today. There's 900 software companies, and they range from small agile startups all the way through to the AWSs of the world that have thousands of software engineers. And we in Genesys would be in the middle of that pack, and we see ourselves as having really interesting careers for software engineers as part of that. But there are a lot of jobs out there, and that isn't going to go away for a long, long time. Software engineering is going to continue to grow very rapidly. And there's, at the moment, it's 24,000 software engineers in Ireland, and that's going to grow. I'd say that's growing at about 20% per year. And these are very well-paid opportunities, and we need to connect our young people with this very dynamic part of the economy. I keep reading in the papers about transient workers in the tech industry. I absolutely challenge that down to the core. While there are a lot of people coming in on visas to fill the open roles that we go and fill through our education system, 80% of the jobs go to Irish people. So we need to continue to connect our young people with this most dynamic part of the economy, and enable them to grow and have fantastic careers in tech and in software engineering, like I've been lucky to have. So with that, I'm just going to say thank you, and we'll hand over to Michael.
Thank you very much, Joe. That was thanks everyone. I think they were really interesting presentations. I'm sure everyone would agree, from Joe and from Claire. And I'm going to talk about careers from the university lens, but I think we'll find some of the same messages coming through, even though we haven't synced up our presentations or anything. But it's just what Joe was saying really is true. So I'm Professor Michael Madden. I'm the head of School of Computer Science here at the National University of Ireland Galway. And I want to talk about studying computer science at NUI Galway, obviously, and the careers that are available for graduates of computing and related degree programs. So by way of, oh, did I hear? I didn't hit share yet, excuse me. Hopefully you can see that now. I missed a click there. So by way of summarizing, outlining what I'm going to talk to you about, I'll start with here are my key messages for you. And I have a few of them. The first is that, I really believe that computer science is an excellent field of study for your students. It impacts everything we do in the 21st century. It leads to a great range of career options, as Claire and Joe have really visualized. Again, emphasizing points they've made, computer science is for everyone. It's for girls and boys. It's for extroverts and introverts. Exactly as Joe said, you don't have to have prior experience of coding. And Claire was living proof of that. You don't have to be someone like a gamer or a techie. So I think occasionally some parents and some perhaps career guidance teachers, try to single out those students that they think are really into tech and say maybe they're the ones who should do that kind of career. But really, it's open to anyone, and we, as Joe alluded to, when you come to university, when students come to university, we teach them everything from scratch. It's lovely if they have some experience of doing things at home, that will certainly stand to them. But what they'll have done, that will have been very informal, and we'll start doing things in a much more structured and formal manner anyway. So, and of course, the last point I want to make is that there's a great range of computing programs in NUI Galway, and several different avenues, which I'll talk about. Obviously, many of you know NUI Galway, but just some brief statistics. It was established over 175 years ago. It's one of Ireland's 7 universities, a lovely campus in the middle of Galway City, links to universities across the world. We've got about 18,000 students and 2,600 staff and 110,000 alumni right across the world. This is a picture of our quadrangle. This picture was taken sometime after the university was founded, called Queen's College Galway, back in 1845. Depending on your age, some of you will know it as University College Galway, which was when I was studying as a student here. The original quadrangle building, the original building of the university campus, is still at the heart of the university. And though, of course, since then, not only have these trees grown to be huge, the whole campus has transformed since 175 years ago. Now, NUI Galway ranks among the top 1% of universities in the world. We have some of the world's leading researchers. We continue to expand our campus with new buildings opening, transforming the campus. And I think, of particular interest maybe to careers guidance counselors, 98% of our graduates are either working or in further study within 6 months of graduating. So we're one of Ireland's top universities for graduate employability, and that's something we're very proud of. As I mentioned a couple of minutes ago, I'm the head of School of Computer Science. This was established back in 1991 as Information Technology, and it became a School of Computer Science quite recently in 2019. We have 28 academic staff, 7 support staff, 40 research staff, but we're actively recruiting about 6 or 7 roles right at this moment. So we're growing strongly too, reflecting the growth in computing in an ICT industry. The university's School of Computer Science is growing as we try to expand intake and cater for all of the kind of industry demand we see for this, for these roles. We've got about 400 undergraduate students across multiple degree programs and about 280 postgraduate students at the moment. We're also a high quality, a high ranked school. In these rankings of universities, as well as doing overall university rankings that places NUI Galway in the top 1% in the world, they do rankings by subject. And here's a screenshot of the rankings from I think it's last year. And we can see NUI Galway was ranked 2nd in Ireland, in the same, a little below UCD and in the same band as Trinity, but above Trinity and UCC. And we're very proud of that, of course. So that's a bit about NUI Galway, but I suppose the next question is, who needs computer science and IT? Well, I suppose my answer to that is always everybody needs computing systems, but only some people get to create the next generation of computing systems. And students from your schools, if they study computer science and related courses, then they will have the ability to create the future. So who needs computing systems? Well, obviously in the medical industry, we're unfortunately painfully aware in the last week of from the hack on the HSE of just how fundamental computer systems are in modern medical industry. Operating systems, this is a picture of surgery taking place. So this surgeon is using 3D virtual reality telepresence, looking at what's going on inside of the patient, and it's sort of enlarged. And then the surgeon makes movements with their hands and at human scale, and these are scaled down to much tinier, finer movements by the robotic system. So the surgeon is controlling everything, but interacting through a computer. And this is possible because of robotics, virtual reality, image processing, and real-time networking, all topics that we cover in our degree programs. Obviously, since March 2020, there's been a huge surge in people working and studying from home. This is entirely possible, as Joe kind of mentioned. It would not have been possible 10 years ago. But because of advances in networking, communications, cloud computing, and all of these technologies that our students study, it is now possible. And it has been, a painful but possible transition for a lot of people to switch to working from home, as well as all the interesting home automation systems, these Alexa devices and all of the rest that everyone finds so nice and useful. For the future, smart energy will be an important element in tackling climate crisis, and software is fundamental to that. Autonomous vehicles of the future will also heavily depend on real-time computing systems and artificial intelligence, and current cars have some semi-autonomous features like collision avoidance and lane following that depend heavily on AI and computer vision. We study, our students study artificial intelligence and machine learning. In fact, that is my own research area, as Anne mentioned in the introduction. And these are really transforming how we use computers, and they have huge numbers of applications. And our researchers are working on exciting ethical applications of AI in science and engineering and medicine. Before I move on to the next phase of my presentation, I wanted to leave you with one thought about it. I think that software developers are the modern inventors. When I was 10 or 12, I wanted to be an inventor, but I didn't know what an inventor really was. I didn't know how to be one. I used to draw rockets and cars in my son's copy, but I didn't know how to build them, and I didn't think I was ever going to work for a race car company or NASA. But then as a teenager, I discovered computers, and I found out that as a programmer, I could imagine programs and make them real, and I didn't need anyone's permission, and I didn't need to be part of a multi-billion-dollar company. All you need is the imagination to come up with an idea and the technical skill to write the software. You can change the world from a laptop in your bedroom. So all we ask is that your students come to us with their ideas, and we will give them the skills to change the world. So with that then, what are the career paths for computer science graduates? Well, our graduates of GY 350, BSc in computer science and IT, work in all sorts of areas. These are logos of some of the companies around Galway and around Ireland, because most of our graduates stay in Ireland, though some choose to travel abroad, but they're never required to. They work in all sorts of areas, from product development, games, finance, multimedia, R&D, telecoms, internet technologies, medical, consulting, even entrepreneurship. Now, sometimes people find the entrepreneurship one surprising. They might think that if you wanted to start a company that you're interested in that maybe you should study business. But I think as Joe's story that he outlined to us shows, and this is true if you look right across across businesses that produce products. Product businesses are almost always started by people with technical skills, not with business skills. People who can build a product or a service that can solve problems for people. And software companies are started by software engineers. And then as they become successful, they bring in the business people to help the company grow. But entrepreneurship, if that is somebody's passion, a technical qualification of computer science is a great place to start. Obviously, I've been working as a software developer basically all my life, and I believe it's a great job. But you don't have to believe me. Every year, US News does a survey to identify the 100 best jobs in America. And in 2020, 2021, here is their ranking, and it puts software developers number one. There's also a related job, statistician, at number 6. In reality, modern statisticians do a lot of software development. Other roles like dentists, physician assistants, and nurses, and that are the other top ranked jobs. Personally, I prefer to be working on developing code than looking into someone's mouth. Salaries are great, and there's a lot of possibility for salary growth in computer science. In NUI Galway, I'd like to tell you about the pathways available. We have a great range of possible ways of studying computing. Our core program that I'll talk more about is BSc in Computer Science and IT, but there's also electronic and computer engineering and electrical electronic engineering. Really, you could think of these three as being on a scale. If someone wants to work mainly on software, they would do the computer science. If they want to work on hardware, they would do electrical electronic engineering, or they might go in between with electronic and computer. And as for the difference between hardware and software, well, the old definition of that is if you can spill your coffee on it, it's hardware. And otherwise, what runs inside the hardware is the software. Often graduates of these programs, of course, go straight to industry, but we also have a range of postgraduate programs as well, to where people can do even more advanced studies up to PhD. We have a Bachelor of Arts degree with IT as an option, and students who graduate from that, or students who graduate from other degrees, such as business or engineering degrees, other than electronic, often would do a 1-year higher diploma to gain kind of detailed skills before moving into the software industry or moving on to advanced studies. And we have a range of online and traditional class-based postgraduate diplomas for people without core degrees in computer science. So our GY 350 then, Bachelor of Science in Computer Science and IT. This is really the university's core computer science software engineering degree. It's a 4-year honors degree with 8 months of work placement. Students develop a strong and broad base of computing skills, lots of emphasis on teamwork and hands-on projects and working together. The kind of things I know that Claire said that she was afraid would not happen if you studied computer science. There's an optional stream with extra maths for people who like that. It's a highly respected professional degree because it's accredited by Engineers Ireland as a software engineering degree, and lots of problem-based learning in a range of different topic areas. It's great for students who have an interest in problem solving, creating new things, and research. And they've got a good standard of maths, physics, or other numerous subjects, exactly as I think Joe said a while ago. There are other ways to study computing in NUI Galway: Bachelor of Arts, BSc in Science and Engineering. With the Bachelor of Arts in NUI Galway, as you might know, it's a 3-year degree, and you graduate with a double major, 2 different subjects. In first year, you pick 3 subjects, and then you specialize in 2 for the 3 years of your BA in Galway. And in Galway, unusually among universities, one of the subjects you can take along with philosophy or French or German or English or many things is information technology, and that's a solid computing degree course. Now it's half of a 3-year degree rather than a full 4-year degree, so it doesn't have quite the same depth as our GY 350 BSc in computer science, but it's still a very strong and good base for a future career. And graduates of that degree, their careers are often informed by the other subject that they took as part of their BA. So if they studied something like languages, they might go into a career in journalism. If they've done foreign languages, they might go into a career in translation and so on. But they work across many different industries as well. Coming towards the end of my presentation now, and I just want to give you a snapshot of all of the pathways we have in NUI Galway for a career in computing. If you do the standard science degree, GY 301, that has computing pathway and computing and maths pathway as well. And even interestingly, students could transfer into GY 350, the computer science and IT degree at the end of first year. If you do the master's or bachelor's engineering degrees in NUI Galway, we've got undenominated engineering in first year. And from that, as well as transferring into any of the engineering subjects, you could transfer into computer science at the end of first year in that as well. But if you stay in engineering, there's a great choices to do for a career in computing would be to do either GY 406 or transfer in from undenominated into a GY 406 or GY 414, electronic and computer engineering or electrical and electronic engineering. Then through the BA, there's the information technology subject in GY 101 that I already mentioned. There's also interesting other subjects like digital arts and technology in the BA, which is a lot of computing. And this other course that I really want to highlight here, GY133. This is a new BA in education, computer science and math studies. This is for, if you know any students who are interested in becoming secondary teachers, obviously there's this new computer science Leaving Cert course, and to qualify them to be able to teach that Leaving Cert course in computer science and to be able to teach maths or applied maths, they can do GY133. So I think that's a really interesting new option and a career option. And of course, then there's GY350. For more information on some of our programs, you can get information from our website. You can find us on Twitter and Facebook. You're always welcome to email me or email our general kind of mailbox, computerscience@NUI Galway, which is our administrators will pick up and route to the right people. If you've got any questions about student choice and so on, there's a link here, and I can make these slides available if people wish, so you can find these again. There's a link here to our most recent online open day, but I'm pleased to say that in-person open days will be resuming in the autumn, so please encourage students to watch out for them. And we'll also be running our computer science summer camp towards the end of the summer in August or possibly September. And we're going to run that as a hybrid experience. People can either choose to do it online or do it in person. That's all I have for you. Thank you very much for your time and attention. And I really welcome your questions. And as I finish up, I'll just leave up those key messages that I had to communicate at the start. Thank you then.
Michael, Claire, Joe, thank you very much for giving us an amazing overview of computer science and the options and your career paths to date. I'm going to open it up to the floor now. So if anyone has any questions, you can either message it in the chat function or unmute yourselves and please ask the panel directly.
So I suppose I'd have a question to the floor, which
I see there are some also questions typed into the
box,
chat.
yeah.
So maybe there was one for you, Joe, saying that do Genesys recruit other engineering graduates such as mechanical?
we're very much computer science, I'm afraid. There are other companies like Schneider and those who do engineering, the wider engineering degrees. We're very much focused on computer software.
Yeah, and I see you've actually answered that as well. And I saw there was a question as well about maths, for computer science, and I agree with what you said. If they're doing well in maths at all, look, even if they're getting, a H5, H6, they'll be well able for it. It's probably we don't do very hard maths in computer science degrees and in computer science industry, but the reason why maths is, I think, as Joe was alluded to in the answers there, is because why it's important is because the kind of mentality of problem solving and breaking problems down and formalizing them. There are lots, from Julie asked, there are lots of postgraduate options available. I had one slide there showing, that large one showing all of our different options. So yes, so there are conversion courses, 1 year higher diplomas in software engineering, 2-year masters in software engineering, and options then even from people who, if you get first class honors in that higher diploma, you could move into one of our advanced master's programs in artificial intelligence or so on.
Michael, in relation to your summer camp there, what is that? Who is that for, that age group that you run that for?
So TY and above, or TY in 5th year, that kind of ages.
Sorry, can I just ask a question of Michael? Michael, I know the maths requirements for the computer science course are well signposted, but for a student coming into the BA and doing IT as one of the subjects, there isn't that same maths requirement. No. How do students struggle? Some of them, or is the maths a little bit, I don't know, is easier the right word, but
well, I suppose in the BSc in computer science, as with engineering programs, because it's kind of a scientific and engineering degree, they do quite a bit of maths in the first year. They do, a maths course is more or less is kind of a recap of some of Leading Cert Maths, and they do statistics and they do those kinds of subjects. So whereas in the BA, they don't have that maths requirement. And we know that the students, in designing the modules that we teach the BA students, we don't have the detail, or we know that they don't necessarily have honours or close to honours maths. So we don't have the same expectation, and we bear that in mind as we present and develop the material to not throw a load of maths at students that they might not be familiar with. So often, when you're presenting ideas in computing, you can present them in a sort of a slightly more formal mathematical way, or a somewhat more informal non-mathematical way, and that depends on the student cohort you're dealing with.
Michael, hi Barry. Michael, could I ask a question?
Sure.
Connie Kelly here. It's about computational math. So is that actually the underlying type of math that's actually delivered in a computer science course? I'm considering, let's say, the fact that we have project maths at second level, and in terms of students who are finding project maths actually not a suitable type of maths for them, are we really looking at computational maths for students who are more attuned or more organized within themselves to actually pursue careers in computer science?
Yes, I mean, apart from, say the first year formal mathematics modules that students in first year computer science do, the rest of the mathematical content outside of that is not as heavy as you would encounter, and even first year maths is not, I think, as hardcore to some extent as you'd encounter in Leading Cert Maths, honours maths particularly. These things of theorem proving and some of these things that are kind of challenging and a little artificial, we don't worry about them. We don't bother with those kind of things. That's not an important part of it.
I suppose that's what I'm finding in terms of trying to explain how suitable computer science is for certain students. It's actually trying to translate the type of maths, or try and identify the type of maths that people might actually naturally like, but aren't necessarily availing of it through the educational system as it exists today.
And again, no more than everything else, assuming people come in with the basic prerequisites, we will.
I understand
teach them
that.
all of the content. Well, I don't understand. I'm afraid I'm a little out of touch with my Leading Cert syllabus. So what is it do you think about project maths that they would?
I suppose it's the emphasis. It's the emphasis on solving problems, but it has more. It requires more of an input on comprehension as opposed to the technical skills of math. That's what I see.
Yes, and really the comprehension side, is sort of important,
Yeah, of course.
But I think what can be very challenging about the Leading Cert is while I think it was a good idea to try and bring in problem solving, I think it's extremely unrealistic to expect, in a 2.5 hour exam where there's intense pressure on students, that they will have the kind of clarity and sort of presence of mind to figure out how to solve problems. I mean, sometimes when I'm trying to solve a problem, I'll take half a day to do it, and I might have to go to walk and clear my head and figure things out. And as software engineers, we spend a lot of our time solving problems, but trying to solve a problem, with a gun pointing to your head is never going to be good.
I understand.
So I think in the real world, and even in our university assessment, we far more continuous assessment, far more opportunity for students to work over a somewhat longer period to take reflective approaches to solving problems, as opposed to this 2.5 hour exam on a Wednesday morning, you know, with the pressures of the world riding on it.
I suppose I'm also thinking ahead to people who are considering converting or changing to computer science after having another qualification as well. So I'm just following the trend of where maths actually can be an obstacle for certain clients or people who actually could be considering computer science, but have this concept that they couldn't manage the maths. So thank you.
And again, I think a point there, and it's maybe one that's hard to communicate sometimes, is that, you know, it's not so much that we will use a lot of maths, and the reason why there's even any sort of extra maths requirement at all, it's not because they use a lot of maths, very complicated maths every day. Some software engineers do, and when I'm working on machine learning stuff, sometimes there's a fair bit of maths in that, but not normally. It's more that the mentality that allows you to tackle maths problems can be useful to help you tackle computer problems.
Yes, and that's what I'm looking.
So it's about the mentality, but also there are lots and lots of careers where you know, a huge diversity of careers, as I think Joe gave an indication at the start, and you don't really need to worry about being a mathematical person. As I tried to say, it's open to any people. Sorry, Joe, you had a point in there?
It's an obstacle, thank you.
There's a question there in the chat about how do students who come in with all ordinary 2 succeed compared to honours maths?
They do just fine. We've actually done formal analysis of that, Joe, because Engineers Ireland, who accredit our degree programme, you know, they normally accredit engineering degree program where there's a requirement to have honours maths, and they used to be nervous about the fact that we would allow some sort of ordinary, you know, higher grades in ordinary maths. And so we've had to do detailed analysis of how students have they succeeded or failed.
I think this is,
and it has become clear from our analysis that there's no real difference. I see a question about links to summer schools. Sorry, there's some background noise, but
Tara, can you mute?
I'm afraid I don't have the links just yet because we have not finalized. Our colleagues who are organizing the summer schools have not fully finalized those details because we're still awaiting kind of, you know, general government guidance on when things will go ahead before we announce the summer school. So all I can ask you there is to please maybe watch our social media or send us an email message if you'd like to be informed when we have more detail.
Okay, thanks everybody. I think you'll all agree that was a super job and really good review on the pathway from being maybe a TY student to where Claire is today, or Joe as a computer just. Michael, that was fantastic. The whole overview and the whole conversation with Connie around maths is really important because I think students get bogged down with this idea if they're not a H1 in honours maths, they're not going to be able to do computer science. So there's a whole area there that needs to be explored more, I think, and talk to students about it. Especially female students. I think girls at times can give up on maths too early before they even try, and they just have this preconception that it's not for them. So there's so much that can be done, and companies like Genesys coming in today and working and talking to the career guidance teachers and talking to students, as they've been doing over the last number of months. The Galway Science and Technology Festival has been running a career talk series. Medtronic, Cisco, and Genesys have all spoken to, and Boston Scientific has spoken to students online. They've been really successful, and it's a great way to engage with the students easily online, which makes it so simple. Thank you, Michael. Thank you, Joe, and Claire. Great career story there, and to Tara for moderating the Q&A as well.